Integrals.
Alright, so for integrals, the power rule that's pretty much your generic equation for the power rule when you're taking the antiderivative of pretty much everything you're doing in integrals. Constants integrate into x. I guess that's an example. You can see that the x squared turns into a x cubed, and then you have to divide every part by the exponent plus 1. Remember to add c, simplify, so if there was a 3 in there, then you would just cross out then x cubed. Pretty self-explanatory. One of the concepts in calculus is the area between two curves. Vertical slicing is one of the two that fall under. The generic equation for vertical slicing is f of x minus g of x and d of x of both of those. The interval of a and b where f of x and g of x intersect, that's a graph example of the two functions x squared and x. So when you're finding the interval between 2 and 4, you would take the first equation minus the second equation, and then you would take the antiderivative of that, and you would get x cubed over 3 minus x squared over 2. Then you would have to pretty much plug in your two points and subtract them from one another. So you would plug in 4 into the antiderivative equation you got, and then you would plug in 2 and you would subtract your answers. You would get 2 over 3 at the end. For horizontal slicing, it's pretty much the same thing, except you would be taking you would be taking the derivative of everything in respect to y. The equation is pretty much the same. It's just f of y minus g of y. This is another graph of other examples, y squared and y plus 6. So you would pretty much you would make your equation and then take the antiderivative of the equation. You would get converting those two graphs into the next thing, and then you would take the antiderivative. After that, you would just plug in your interval numbers into each one. For this one, you don't have to do it for 0 because you wouldn't get anything, so you would just take it for 3, plug in everything for 3, and then you would get your answer. If you don't get an interval, then you would have to set the equations both equal to 0. Right here, you would just set it to 0, and then you would have to factor it out, and you would get your interval, and after that, you would pretty much continue going on with what you would normally do. Just get your equation, take the antiderivative, plug in for each of the two interval numbers, and then you would subtract them, and then you would get that.
So on this slide you can see integrals of trigonometric functions.
And on this slide is u substitution, which is another form of integration where you would let u be your function and then use the power rule. So in the first example, you have your original equation, the integral of x cosine of x to the fourth plus 2 dx. So then first you would take the integral of that, and then you would, what is that? Oh, and then you would cross out the x cubed, and then you would just have 1/4 of the integral of cosine u du, which is then equal to, once you take the integral of that, you would get 1/4 sine u plus c, and then that would become 1/4 sine of x to the fourth plus 2 plus c. And this is another example where the original equation is the integral of the square root of 2x plus 1 dx. So then you would let u equal to 2x plus 1, and then du over dx would equal 2, and du would then be equal to 2 dx, and then dx would equal du over 2. So then you would solve for u, and then you would have an exponent of 1/2, and then you'd integrate that, and it would become u to the 3/2 over 3/2, and then that would simplify to 2/3 u of 3/2. So then you would substitute that back in to the equation here, and then you would multiply 1/2 by 2/3 u to the 3/2, and then you would add c, and the answer you would get would be 1/3 times 2x plus 1 to the 3/2 plus c. So the definite integral is based on the fundamental theorem of calculus, which states if f is continuous on the closed interval a, b, and the derivative of f is equal to f, then according to the fundamental theorem of calculus, f of x is equal to f of b minus f of a, which is the definite integral of f from a to b. So this tells us that we are able to evaluate any definite integral for which we can find an antiderivative of f. So the first example starts off with the equation 3x squared minus 2 dx on the interval -1 to 2. So then you would solve that to 3x squared minus 2 dx is equal to x to the x cubed minus x squared on the interval of 2 to -1. So then you would just input those values, and you would get 4 for 2 and -2 for -1. So then you would just subtract -2 from 4 and get 6. And then there's the second example. I'm not gonna go to.
Alright, this slide is for midpoints for area under a curve. And basically, you just find your change in x, which is b minus a over n. And then you find the midpoint for each rectangle by using the formula LR plus RR over 2, with L and R being the sides of each rectangle. Then to calculate the area, you use the equation A equals change in x times fn1 plus fn2, etc., with n being each midpoint. So this is an example, which is f of x equals x squared, which is your equation, between 0 and 2, and your n is 4. So to find your change in x, you do b minus a over n, which is 2 minus 0 over 4, which is simplified to 1/2, and then you find your sides of the rectangle, or rectangles, which is here, and then you use that formula to find the midpoints for each rectangle, and those are 1/4, 3/4, 5/4, and 7/4. And finally you plug those into the equation here, and basically that gives you 2.625 as your area under the curve. And this is a picture of that.